Equivalent ratios or equivalent fractions are fractions that have the same value even if they look different. For example, we've got here 1/2. One of the squares is red out of 2 squares. So we've got 2 squares in total. That's why we have 2 at the bottom, but only one has been colored in red. So we've got 1/2, or 1 to 2 when we're looking at a ratio. Over here we've got 2 out of 4 because we have 4 squares in total and 2 have been colored red. That's why we have 2 out of 4, or 2 to 4. We've got 3 out of 6, so 3 over 6. 3 because 3 are colored in red. 6 is because we have 6 in total. And if we write it in ratio format, we've got 3 to 6. And then we've got 4 out of 8, so 4 eighths. 4 are colored in red. 8 is how many squares we have in total. When we write it as a ratio, we have 4 to 8. But how are they all the same value? Well, if we look at it, they all represent 1/2. This is 1/2 of all of the squares that we have. So we've got 1/2 colored in. We got 1/2 of all of the squares colored in here because we've got half of them. See? We've got 4 in total and only 2 are colored in. We've got 1/2 of all of the squares colored in here because we've got 6 squares in total and 3 have been colored in. And we got 1/2 right here because we've got 8 squares in total, but only 4 are colored in. So even though we all have different fractions, they all represent the same thing, which is 1/2. Now, how do we do this with numbers? Okay, well, let's take a look over here. Let me just remove what we've done, and let's do this with numbers. So we will get a question that will tell us, okay, find an equivalent fraction. How we can get to the same amount without looking at a picture like we have here. Okay, so we've got here 1/2. And we know that all of these are equivalent fractions. But how did we get there? Well, if you look at it, if we multiply this 1/2 by 2, multiply the top and multiply the bottom by 2, we get 2/4. That's this one right here, 2 out of 4. What if we multiply it by 3? 1 times 3 is 3. And 2 times 3, right here, is 6. So we've got 3 out of 6. What if we multiply the 1/2 by 4? Well, 1 times 4 is 4. And the 2 at the bottom times 4, we would be 8. So technically, in order to get an equivalent fraction, we grab the fraction that has been given to us and we just make sure we multiply the top and the bottom by the same number. So let's go back here to what we had. We started with 1/2, which is what we were given. If we multiply these by 2, both the top and the bottom, we get 2/4. If we multiply these by 3, we get 3 and 6. If we multiply it by 4, we get 4 and 8, and we can continue. We multiply by 5, we'll get 5 and 10, and at the end, they all have the same value. They're all equivalent fractions. What if we were asked to find equivalent fractions to both of these numbers that we've got here? So we've got 1/3 and 10/20, and we're asked to find an equivalent fraction, or find 2 equivalent fractions for each one. Okay, so we can start by picking a number. Let's pick a number. 2. Great. Let's start with 2. So we're going to multiply the top and the bottom by 2. So if we multiply it by 2, we're going to get 2 over 6. That's one equivalent fraction. Okay, let's pick another number. What about 3? Okay, so we're going to multiply the top and the bottom by 3. 1 times 3 is 3. And 3 times 3 is 9. All right, well, what's another equivalent fraction? Well, let's go higher. Let's pick a number. Let's go with, I don't know, 7. Okay, let's multiply the top by 7 and the bottom by 7. That's going to give us 7 over 21. All of these are equivalent fractions to 1/3. What about this one, this 10 over 20? Well, we can do the same thing. We can pick a number and multiply. So let's start with 2. What's 10 times 2? 20. What's 20 times 2? 40. Okay. We can pick 3. Let's multiply the top by 3 and the bottom by 3. 10 times 3, 30. 20 times 3, 60. But another thing that we could do is, because this is 10 over 20, this fraction can actually be reduced further down. Doesn't necessarily have to go all the way up. So we can actually divide the top and the bottom by a number that fits into both. So for example, what timetable will give us 10 and will also give us 20? Well, the 10 timetable. So we can actually divide both numbers by 10. 10 goes into 10 once, and 10 goes into 20 twice. All of these are equivalent fractions of 10 over 20. So when you're asked to find equivalent fractions to a number, all you have to do is multiply the top and the bottom of that number by whatever number you want. It could be by 2, by 3, by 4, by 5, as long as you're multiplying the top and the bottom. You can do that, or when you have a number that can still be reduced, you can also divide that number by the same, of the top and the bottom by the same number. Like we did over here, we divided the top by 10 and the 20 by 10, and we ended up with 1/2. And all of these are equivalent fractions. Remember that equivalent fractions can also be expressed as ratios. For example, 2 over 6 can be expressed as 2 to 6. 3 over 9 can be expressed as 3 to 9. 7 over 21 can be expressed as 7 to 21. Same over here. 20 over 40 can be expressed as 20 to 40. 30 over 60 can be expressed as 30 to 60. And 1/2 can be expressed as 1 to 2. This is why finding the equivalent fraction is the same thing as finding the equivalent ratio. Okay, let's take a look at a word problem here. So we have Annie picks 2 apples for every 3 pears. The ratio of apples to pears is 2 to 3 because we have 2 apples for every 3 pears. That's why we have 2 to 3. How many apples would Annie pick for 6 pears? Okay, so essentially what we're trying to find out is how many apples we need. So if we said that we have right now 2 apples to 3 pears, so that means 2 represents the apples and 3 represents the pears. What we're saying is we're missing something here when we have 6 pears. So we're trying to find out what number goes here, which is an equivalent ratio. Let's do this as a fraction. We have 2 out of 3, and we're missing the number that goes here in our equivalent fraction, but we have a 6 here because this is 6 pears, and we're trying to find out how many apples would we need to have 6 pears. So what we need to do is we need to find out what number are we multiplying this by in order to get this equivalent fraction. So what number are we multiplying the 3 by in order to get a 6? Well, 3 times 2 is 6. And we have a rule when we have fractions is that whatever we multiply to the bottom, we also multiply to the top. So if we multiply 3 times 2 to get a 6 at the bottom, we multiply 2 times 2 to get the number that's missing at the top, which is 4. So how many apples would Annie pick for 6 pears? She would pick 4 apples. Okay, we have a different way to do this, and it's also we can look at this visually. So imagine we've got, these are my apples. They're not the best apples. But for 2 apples that Annie gets, okay, all right, she's also going to have 3 pears. And 1, 2, 3. Okay, these are my pears. So if we need to have 3 more pears so that we have 6 in total, okay, so we need 3 more right here. How many more apples do we need? So we have for 3 pears, we get 2 apples. Now we have another 3 pears so that we have 6 in total. We're missing how many more apples? 2 apples. Because every time we have 3 pears, we get 2 apples. And so we're adding 3 more pears. We need to add 2 more apples. All right. So how many apples do we have in total? 4. So Annie would need to pick 4 apples in order to have a total of 6 pears. So again, this is visually. You can use it. You can draw it if you want to draw it. Or you can use numbers by finding the equivalent fraction that will give us the missing number, which is what we had here. Okay, let's change our problem a little bit here. What if we have Annie picks 3 apples for every 5 pears? So she gets 3 apples for every 5 pears. The ratio of apples to pears is 3 to 5. How many apples would Annie pick for 15 pears? So again, let's put this into a fraction. So we've got 3 apples for 5 pears. We're trying to find out how many apples, so the missing number is here, if we get 15 pears. So once again, we're trying to find an equivalent fraction to 3 over 5. And in order to do that, we had to multiply both numbers by something. Okay, so what did we multiply the 5 to in order to get 15? So we multiply the 5 to 3, because 5 times 3 equals 15. So whatever we do to the bottom, we got to do to the top. So we also have to multiply that by 3. So 3 times 3 is 9. So the answer is Annie would have to pick 9 apples in order to have 15 pears. And remember that this 9 over 5 over 15 can also be written as a ratio of 9 to 15. And that would be our answer. We might also be asked to show if there are 2 ratios that are equivalent. For example, are the following equivalent ratios? And we've got 1 to 2 and 7 to 14. And we're supposed to say whether or not they're equivalent ratios. So there's 2 ways that we can do this. One way is using a cross multiply rule. So we're going to put these into a fraction. So 1 over 2 and 7 over 14. So this is the first way. I'm going to separate our page here so that we show the other way on the other side. Okay, so what we're going to do is we're going to multiply this by this. Okay, and then we're going to multiply this by this. So we're cross multiplying. If we get the same result on both, then the fractions or the ratios are equivalent. So what's 1 times 14? Well, 1 times 14 equals 14. Great. Now the other side. What is 2 times 7? Well, 2 times 7 is also 14. Which means that, yes, these are equivalent because we get the same result when we cross multiply. So this is how we know if 2 ratios are equivalent. We just do the cross multiply, and if we get the right answer with the same answer for both, then they are equivalent. If we get different answers for both, then they're not equivalent. Okay, the other way that we can find out is, once again, we put them into a fraction and the other into a fraction. And we technically have to look at this and say, okay, is there a number that I can multiply this to that will give me a 14? And if I multiply that same number to the top, will give me a 7. So in this case, if we multiply the bottom by 7 and the top by 7, what do we get? Well, 2 times 7 is 14, and 1 times 7 is 7. So in this case, we know that they are equivalent because there is a number that if I can multiply it by the bottom and I multiply it also to the top, we get this fraction right here. What if the answer would have been something else? Maybe this fraction would have been a 6 and a 7. Well, in that case, it wouldn't have been an equivalent fraction because there is no number that we can multiply the 2 by and also multiply the 1 by that will give us a 6 and a 7. Let's show that right here. If we had 1 over 2 and our other fraction here would be 6 over 7, and we need to show if these are equivalent, we'll say, okay, what can I multiply the 2 into that will give me 7? Well, there's nothing. 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So I don't have anything that I can multiply the 2 by that will give me a 7. So that means that this could not be equivalent. If we were using our cross multiply, we can also check by doing what we did before, which is we multiply both sides and we should get the exact same answer, and that's how we know it's equivalent. So what's 2 times 6? 2 times 6 equals 12, and 1 times 7 equals 7. So we know that, nope, this cannot be equivalent because we don't get the same result as we did when we cross multiplied over here. So that's how we know how to solve when they're asking us if two ratios are equivalent. We put them into a fraction. The easiest way is to do the cross multiplication. We should get the exact same answer when both of them. Or the other way that we can do it is put each fraction side by side and determine if there's a number that we can multiply the bottom and the top by that will give us whatever the other fraction is.